Let's go with part 6 of our trig review. This should be the end. You can hope, huh? Part 6. So we're going to do a couple of trig identities. So here is one of them. It's got the sine of alpha minus beta. It is number 73 if you've got your sheet. So sine of alpha minus beta multiplied by the cosine of alpha plus beta. Cosine of alpha plus beta. And it's supposed to equal the sine of alpha times the cosine of alpha minus the sine of beta cosine of beta. Now there's actually an identity that is printed a lot of times for stuff like this. I'm trying to prove it though, not just use it. So first of all, let's take this one and expand it. Sine of a difference of angles is the sine of the first part. Cosine beta, the plus minus stays with the sine one. And then this one's sine beta, cosine alpha. Now this is got to be multiplied by the cosine of alpha, cosine beta. Sum has cosine, cosine minus sine, sine. So sine of a sum, or cosine of a sum, sine alpha, sine beta. So I need to multiply that stuff out. So here we go. These two, sine alpha, cosine beta, cosine alpha, cosine beta. So we've got cosine beta is squared, and then we've got sine alpha, cosine alpha. If I take the insides, so first and then the insides, I should do outsides, I guess, if I'm going to actually spell FOIL, but anyway, do this one, minus the duplicate is the cosine of alpha, so cosine squared of alpha, and I've got sine beta, cosine beta, and then the outsides, minus sine alpha is duplicated, so sine squared of alpha, and then I've got cosine beta and sine beta. So I'll write sine first, cosine beta, all right? And then last times last, we've got minus times minus, so that's going to give us plus. Sine beta is duplicated, so sine squared of beta. And then we've got cosine alpha, sine alpha. So sine alpha, cosine alpha. All right, we've got some squares. So I'm going to take a cosine squared of beta and a sine squared of beta and put those two guys together, all right? So we've got those two, this one and this one. So if I do that, notice they both have sine alpha, cosine alpha. So I'm going to factor that out. Sine alpha, cosine alpha. Factored out, I've got cosine squared of beta plus sine squared of beta. Okay, so those two are together. Amazingly, that's equal to 1. That's kind of what I was looking for. Now, we've got two minuses. This is cosine squared of alpha and sine squared of alpha, and they've got sine beta, cosine beta, sine beta, cosine beta. So let me factor out minus, and then sine beta, cosine beta. So minus sine beta, cosine beta, and see what's left. This one, we took the minus, we took sine beta, cosine beta, we're left with cosine squared beta. We took the minus and the sine beta, cosine beta, so we're left with a plus because we took the minus, sine squared beta, or sine squared alpha. This is equal to 1, so change those out. This is equal to sine alpha, cosine alpha times 1, minus sine beta, cosine beta. And that matches this perfectly. So anyway, looks pretty exhaustive, but we actually got it. Okay, this one is not an identity proof. It is find the cosine of theta. So find the cosine of theta if the tangent of theta is equal to 2/5, and theta's in quadrant number 3, okay? So I'm all about triangles. In fact, I'll draw it in the third quadrant. Now this is not to scale by any means, but the tangent, okay, so here's theta, and tangent of theta, if I use this triangle, is the opposite right here over the adjacent. Well, I'm going to just plant numbers on there that match this fraction. That works fine. So I'm going to do 2, but it's down 2, so I'm going to call it -2. And this one I'm going to use for the adjacent side, and that one is 5, but I'm going to use minus because it's over to the left. So there we go. What's the hypotenuse? Well, -2 squared plus -5 squared is the square root of what? 4 plus 25 is 29. So here's the square root of 29. That's always positive no matter where it is. So cosine is adjacent over hypotenuse. So the cosine of theta is equal to -5 over the square root of 29. Or if you rationalize, which you should do here, multiply by square root of 29. On top and bottom, -5 square roots of 29 over 29. So there's your answer. So that one's kind of nice. Let's see here. This next one has, find the sine of s minus t, given that the sine of s is -1/2, and s is in quadrant 4. The cosine, the sine of t is equal to 1/4, and t is in quadrant 2, okay? Well, sine of s minus t is sine of s, cosine of t, the plus minus stays with us, and we've got sine t, cosine s. I know some of these values, I don't know them all. That one is -1/2. And this one is +1/4. And I don't know the others, so I need to find the cosine of t. Here's t, it's in quadrant 2. So t in quadrant 2, okay, so we've got stuff going like this. This is 1, this is 4. So what's this one? Well, x squared plus y squared is hypotenuse squared or radius squared. So 16 minus 1 is 15, so minus square root of 15. So the cosine, and this stuff is for t, okay? So the cosine of t is minus square root of 15 over 4. Now the cosine of s, sine of s is -1/2. That's actually an angle that we know. That one's a 30-degree angle. But here is -1, that's the opposite side, and the hypotenuse, okay? So 4 minus 1 squaring, okay, x squared plus y squared is the radius squared, so 2 squared is 4, minus 1 is 3, so this is square root of 3. Cosine is square root of 3 over 2. So this one is square root of 3 over 2. So multiply these out. Minus times minus is plus. We've got square root of 15 over 8. 2 times 4. And then minus 1 times square root of 3 is square root of 3 over 8. So square root of 15 minus square root of 3 all over 8 if you want. So there you go. Let's find some other things to do here. We're getting close to exhausting all the things that we can possibly think of. But here is an inverse function. It says this. It says y is equal to the arc cosine or the inverse cosine of -1. Find the exact value of y. Okay. Well, what do we know about this? This tells me that the cosecant of y is equal to -1. Now, if you don't know a lot about cosecant, you could say, okay, that's 1 over the sine of y is equal to -1. And do a little algebra, that gives you the sine of y is equal to -1. Ones are kind of nice. Where's the sine of y equal to -1? It is at this point right here. Okay, now how do we judge it in terms of inverse functions? Do you go all the way around this way or do you go this way? Well, inverses tend to take the shorter route. So we're going to take this direction and go that way, and so it's either minus 90 degrees or minus pi over 2, depending on how the problem is posed. So in degrees or in radians. All right, I've got a few more problems that we're going to deal with here, and we'll try to get some stuff kind of straightened out, see what we get next. Let's solve some equations. So this one is listed as number 77. It's got the square root of 3 times the secant of 2 theta is equal to 2. And we've got theta is between 0 degrees and 360. So we can do this in degrees. And it says round it to the nearest degree. So we may have to round. We may have exact answers. We'll see what happens. Okay, first of all, I'm going to get rid of the square root of 3. So I've got secant of 2 theta is equal to 2 over the square root of 3. Now secant is 1 over cosine, and I tend to think in cosines more than I do in secants. So 1 over cosine of 2 theta. So I'm going to take the reciprocal. So I get cosine of 2 theta is equal to the square root of 3 over 2. Okay? Now, that's a number that I know for sure, so I don't even have to do any rounding. But I've also got one more issue. I've got 2 theta. So if I've got 2 theta, I've got to get answers between 2 times 0 and 2 times 360. So 2 theta is from 0 to 720. So we've got to go around the circle twice to get our answers, all right? Now, what angle gives you cosine is square root of 3 over 2. So 2 theta, what is 2 theta? Well, first one I think of is 30 degrees. And then cosine is positive in quadrant 4, so 30 degrees from the end of the circle is 330. Then I go again, so 360 plus 30 is 390. Got to go around the circle twice. And 720 minus 30 is 690. So I've gone around the circle twice. Now, to answer the question, I divide everything by 2. So theta is, all right, we've got 15 degrees. Half of 330 is 165. Half of 390 is 195. And half of 690 is 345. Notice I'm still within my original boundaries of 0 to 360. So we've got to do a few things there in terms of solving that. Let's see what we get for number 78. Number 78 has a formula. It says t equals 591 minus 76 times the cosine of 2 theta, and it says theta is in degrees. So theta is in degrees, and it says to the nearest hundredth of a degree, what's the smallest positive value of theta, for which the value of t will be 577. So we've got to have 577. So I'm going to put that in. Let's subtract 591 from both sides. So we've got 577, subtract 591 is equal to minus 76 cosine 2 theta. Okay, so this is minus 14, is minus 76 cosine 2 theta. Divide both sides by minus 76. All right, I'm going to go calculator on you. Now I've got to get my calculator in degrees because it said to do things in degrees. So there we go. Now, minus 14 over minus 76. That's the same thing as 14 over 76. Excuse me. So I've got 0.1842. So I've got something here like 0.1842, etc., is equal to the cosine of 2 theta. Now they want the smallest one, so there's only one answer that we need to deal with, but to get 2 theta, that's our first thing to do, we've got to do the arc cosine or the inverse cosine of 0.1842, blah, blah, blah. So I'm going to do that. Second cosine, so that's inverse cosine. Go up and grab that decimal and get the answer. So 2 theta is 79.38489, etc. It's 2 theta. Well, to get theta, then I need to divide my angle by 2, and I get 39.69244,608. It says to the nearest hundredth of a degree. So this digit is less than 5. So theta is approximately 39.69. Now, don't ever cut off your decimals until the very end. That keeps you a little bit more accurate. So that's just a problem that appeared to be a word problem, but it really wasn't. Okay? Now let's do some more solving. So here we've got y equals 7 sine of x. Y equals 7 sine x. And the problem says that x is in minus pi over 2 to plus pi over 2. Now, if you look at domains and ranges and that sort of thing of inverse functions, which this is related to, you will find that the inverse cosine is in this region. So that's why that is listed that way. Now we've got to solve for x. So we've got to get rid of the 7. So divide by 7. So we've got y over 7 equals sine x. Well, how do you release x from sine x? You have to take the inverse sine. So you get the inverse sine of y over 7 is equal to x. And that's all you do, because the inverse sine is in there, and that's an x value. So it's really not as hard as it appears. All right, I've got an equation. I think I better change pages because I'm going to need more space. So let's do this. Number 80. Get this equation. This equation says the cosecant to the 5th of x minus 4 times the cosecant of x is equal to 0. Okay? All right, so I see a common factor. My answers have to be between 0 and 2 pi. That's in the instructions. That tells me I've got to be in radians. So I've got to work this in radians. But when I see this, I take cosecant of x as a common factor out of here. So I've got cosecant to the 4th of x minus 4 is equal to 0. Now from algebra, you probably remember that something times something else equals 0 gives these two options of being 0. So I could have cosecant x equals 0. However, that is 1 over the sine of x equals 0, and it doesn't happen. No solution. So it's not 0, okay? So that one does not provide an answer for us. Next, this one. It's a perfect square, and that's a perfect square. So let's factor it. Cosecant squared of x minus 2 times cosecant squared of x plus 2. is 0. I did it as the difference of squares. Okay, next thing here. We've got two things equal or multiplied that give us 0. So each one of these could possibly be 0. Let's look at this one first. Cosecant squared plus 2 equals 0. This is a perfect square. It is at least 0. As we found here, it can't be 0, but it's at least 0 because it's a perfect square. It's actually more than that because cosecant can't equal 0. You add 2, so you get at least 2 here. Equal 0? No, there's no solution to that. So we don't have any solutions from there. Look at this one. This one has cosecant squared of x minus 2 equals 0. I'm going to write that in signs just because I think more in signs. So 1 over sine squared of x equals, I'm going to move the 2 over, equals 2. So I'm going to cross multiply, kind of flip those over. I get sine squared of x equals 1/2. Okay, that doesn't look very promising, but take the square root of both sides. You get the sine of x. When you take square root, remember plus or minus, square root of 1/2. Okay, that is something that you use a lot in trig, and it's rational. Square root of 2 over 2. Oh, there we go. There's an answer that we recognize. Sine of x is square root of 2 over 2. Our reference angle for that is pi over 4. And sine can be either positive or negative. We've got to go all the way around, so we've got 4 answers. X is, well, it could be pi over 4. That's the first one. What's the pi over 4 reference angle in quadrant 2? It is 3 pi over 4. What about the one in quadrant 3? 5 pi over 4. And in quadrant 4, 7 pi over 4. So you get 4 answers. Now in college algebra, you probably learned that a 5th degree could have up to 5 answers. And trig, a lot of times it has twice as many. This one didn't quite have that many, but anyway, we found all the real answers. The rest of those were imaginary numbers, and that is not something that we have really dealt with. Okay, next problem. We're almost done. A rotating beacon is located at distance d from a long wall. So d equals distance. The distance d is given by d equals 4 tangent 2 pi t, 2 pi t. And t is time in seconds. Okay? So solve the equation for t. Well, I guess I didn't even need that stuff, did I? So let's get t by itself. Let's start stripping things away. So let's take d over 4. So d over 4 equals tangent 2 pi t. How do you release the angle from the tangent? By inverse. So tan inverse of d over 4. So tan inverse of d over 4 is 2 pi t. Divide by 2 pi. And you've got t. So anyway, kind of reasonable. All right, some other values here. 82. Y equals arc sine of minus square root of 3 over 2. So that means that the sine of y is equal to minus the square root of 3 over 2. Remember, this arc sine function is defined in quadrants 1 and 4. So reference angle for square root of 3 over 2 is, and it says real number, so we've got to be in radians. Reference angle for square root of 3 over 2 is pi over 3, but making sign a negative, the answer is going to be in quad 4. It's minus pi over 3. Number 83. I think we're almost there. This one has sine squared of 2x equals 1. So that would be the sine of x, of 2x, equals either plus or minus 1. And if x is between 0 and 2 pi, that means we're in radians, we've got to figure this out. Well, where's the sine plus or minus 1? And we've got 2x, so we've got to go around the circle twice. Well, we've got to go to the 90-degree mark, or pi over 2. So 2x is going to be pi over 2. That's one possibility. Going down, we got 3 pi over 2. We've got to go around the circle twice because of this. So this one is going to be, what, 5 pi over 2? And then 7 pi over 2. So x equals pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. It's on those y-axis lines. So that one's pretty reasonable if you remember some of your exact values. And okay, last question I think here. Y equals minus 5 times the sine of 8x, and x is in the region from minus pi over 16 to plus pi over 16. Okay, so if I divide by minus 5, I've got y over minus 5 is sine 8x. So I take the inverse sine, so sine inverse of y over minus 5 is equal to 8x. Divide by 8, and there we go. Okay, there's nothing else that you can really do with that. The reason that they've got this over 16 is because of the 8. So you multiply this by 8, and you're going to have minus pi over 2 to plus pi over 2, which is where sine inverse is defined. So anyway, I think that is probably sufficient. There are a couple more questions here, but we're going to stop there.